So progress with the build. I've almost finished soldering up the Sprite board here, and this is the replacement version 1.1 of the user port to 24-bit address with auto-incrementing address pointer. This is version 1.0, and if you recall from the previous videos, there were a couple of missing components from this board. For some reason they weren't included in the PCB auto place because they weren't included in the layout. Very strange problem, that one, but okay. So this is the old board. I've just been pulling out gently all of the components from this old board, and I'm beginning to populate the new board. So I'm going to test this one first because I've already just previously tested to make sure that the existing video hardware with what was this board is still working okay. I've printed out the new parts list for the 1.1 board over here, but I just really wanted to show a size comparison between the Sprite board and the user port address board, because this one has many more. Look at all of the soldering on the back here. It's huge. This is by far, I think, the biggest, densest board that I've been soldering up. So not long to go now until this one is completed. So there are a couple of small minor adjustments, apart from it's slightly bigger than the 1.0 board because it includes the extra components that weren't placed before. There is also a little LED, little power LED. So I have some indication on whether or not this power supply that's coming in is perfectly fine. Apart from that, the functionality of this and this board are the same. Apart from this board, the new board doesn't obviously rely on a breakout breadboard containing the missing components. So a few more minutes and this one should be done. And then I'm going to run a test video with just this new one first. And then after I finish populating the Sprite board, then I'll be I'll have another video containing the debug session of this board. And I'm really interested to see if it works first time. I am a little bit concerned whether or not this weak pull-up logic here is going to work with the memory chips that I've chosen. So one thing to note on this board is that I have an option of using two different types of memory chips. On the original bomb jack hardware, the Sprite scanline buffers used two, I think they were two 114s, here and here. The 4-bit fast RAMs, the same kind of 4-bit fast RAMs that are used currently on the palette lookup. So I've not socketed these because I'm going to be using these RAMs, which are 8-bit RAMs, and they hopefully should be fast enough and accurate enough that I don't need these ones. But if these don't work, then what I will do is I will socket these, and then I'll use two 114s instead, and I'll test the design with that, and then hopefully one or both of these will be working. But by preference I want to use these 8-bit RAMs here because it's two single chips rather than 4 single chips here. So we'll see how it goes, but I'm looking forward to testing this new version because it should be a lot more stable. So progress with the build. I've completed populating the user port to 24-bit address with auto incrementing address pointer board, the version 1.1 board. If you can see that over here. It's got the little LED and the LED's on. I'm getting a good sync signal on RGB HV and also getting a good sync signal on RGB S as the telly and the video conversion box tells me. So if I'm going to switch back to RGB HV because generally speaking I like to stay on RGB HV because it uses both H and V signal lines just to make sure that they're both working correctly. So I haven't tested this yet. So this is the first run after populating the board. At least I'm seeing expected, power on state of the video hardware. Nothing's been programmed yet or anything. So what we should see is something that looks like this code. I've been experimenting with the code slightly. So I've actually added some Sprite preparation code. So you can see here on the emulation that we should start seeing sprites, but on the real video hardware I haven't finished populating the sprite board yet, and obviously the sprite board is not underneath the character board, so we won't see this screen with the sprites, but we'll just see the background screen as expected. But I've been adding a whole bunch of extra code to do all of the sprite transfers and stuff, so if I press fire, the emulation shows that the sprites start moving around at different speeds, and it exercises the 32 by 32 pixel sprite functionality and also the full screen height sprite functionality as well. And it all syncs to the VSync. But we'll just see the background screen on this. If I run this on the video hardware, let's see if it works first time. So again, easy transfer, browse, program file, Commodore 64 is on, just to double check, yes. Easy Flash 3 light is on. Hit go. Keep fingers crossed. And let's see what we get. So I'm really hoping for a fantastic first time. Wow, it just works. So if I press space, which is fire on the joystick, then it refreshes the screen again with VSync synchronized memory writes, and everything looks perfect, and it actually looks lovely and stable and all wonderful. So when I add the sprite layer on top, I expect this same code to start displaying sprites. That's going to be really interesting. There's several unknown bits of timing that I've changed in the sprites board and using different memory chips and stuff like that, so I'm going to be really interested to see if it works first time. If not, it'll just mean extra debugging, but I'm really happy with this version 1.1 user port interface board. It works a lot better, and it means that I don't need all of the hacky stuff to do with breadboards replacing the missing components. Things to note on this one is that I've actually tied the display enable information. No, sorry, the display enable are the red and white wires. I've tied the horizontal and vertical border signals to what is it? The address or the data of the user port interface. So what this means is that I'm just using those to get the required signals to open up all of the borders, because now I don't have the breadboards, I don't have a reliable source or any other reliable source of logic level voltage, so I'm just using the extended memory bus. Well, no, the memory and address bus and the data bus here, just to give me those signals so I can pipe them into there. So that's why, actually, if I reset Commodore 64, if I rerun this again, you'll notice that the horizontal and vertical borders will be flickering in and out as it's transferring information to the screen, which is expected behavior, so I'm glad to see that too. Anyway, so the sprite board will need to be populated now, and then I'll crack on with testing that one. But I'm really happy that the new user port board worked first time. So progress with the sprite board build. Here is the socketed sprite board with all of the headers connected up. The soldering all looks pretty neat, and I've checked all of these through my magnifying glass, and everything seems to be okay. So we'll see how this goes. Now, I've already printed out the component layout here, and I've also printed out the 2 sheets of the component listing. So what I've done is that for the first sheet here, I've already laid out the components in order, in the same order that's visible on this sheet here. I'm going to be socketing these RAMs last, because I'm going to be handling the board quite a lot. I don't want the chance that I zap the RAMs or anything like that, even though I'm earthing myself properly. I still don't want to handle the board too much with the RAMs in there. So I'm going to be doing all of these components first, and then the next sheet, and then I'll put these RAMs in last. But you can see here that these are all of the packages. So they start off with 7404 here, and then 7408, 74126, blah blah blah. And then we'll go all the way over to here. And then I'll sort the packages for the next sheet and continue to assemble that. So it won't take too long to assemble this, but I like to triple check everything before I push the components in, just to make sure. Short status update. So the Sprite board has been completed in terms of IC population. All of the components here are checked off, and all of the components on this list are also checked off. Now it's just time to connect it up and see what happens. So progress with the build. I have just stacked the Sprite board on the bottom here, underneath the character generation board, underneath the video board here. So the Sprite board on the bottom, character generation board, video generation, user port interface up at the top. I've connected all of the wires as expected in terms of signals from the Sprite board down here going into the 9800 address select here. Both pixel layers have been connected up. Now the characters are connected to the plane behind the sprite. So hopefully the sprites should be the first plane, and then the characters should be underneath it. The video conversion box is showing a good sync. It's actually 264p and 15.75 kilohertz with 59.66 hertz, which is perfect. The Commodore 64 is just reset there. What else have I forgotten to do? I haven't forgotten to do anything. All of the border X and Y sizes are still plugged in. That's fine. So I'm getting this display, which on the screen at the moment, which is a good sign. It means that the Sprite board hasn't screwed up any of the signals and has been causing that weird signal reflection EMI issue that I was seeing on the ribbon cable. We're going to run this code here. So what we will see under emulation here is what we were expecting to see before, which is this, and then I press fire, and then the sprites should start scrolling. It's the moment of truth. First time. Definitely cross fingers, because this was a huge build just for the Sprite board. It took many hours to do this, so easy transfer. Gosh, I don't know if I want to really see it. It's very late at night. It's 1:11 in the morning. Okay, let's just hit the go button. Commodore 64 is running it behind the scenes. Oh my golly gosh, it's almost pretty much working. So the jumbled character screen in the background is expected, because we have that non VSync timed write to the character memory and the screen colors. I'm noticing a little bit of sprite flickering up here, and there are a few little glitches here. I'm just wondering whether or not these are signal problems, or if this is a bigger problem to do with the sprite logic, perhaps. It might be the same sprite, don't know. Anyway, the rest of the sprites seem to be quite rock steady. So let's just see what we get. So if I press the spacebar, here we go. 1, 2, 3. Press spacebar. Oh, fantastic! Look at that. Okay, so I do notice those slight glitchy pixels on the sprites, but apart from that, look at that. the sprites are actually working. I'm going to move my laptop screen out a little bit. There we go. It works. 99%. I'm going to have to track down that weird little flickery problem on the sprites. It might be one of the signals delaying the sprite fetch, for example, for certain pixel. So don't forget, when it's drawing the sprites, the sprite loading schedule is always every 16 pixels going across the screen for the full virtual resolution of the screen, which is 384 pixels wide, but only 256 are drawn. So that schedule is fixed. So what we might be seeing is that we might be seeing some slightly incorrect signals arriving here, which would be throwing off the sprite load timings here based on the horizontal pixel position. However, that said, I think this is a really successful first test. I think the palettes are actually the same as well. So if I zoom out a little bit, we should see. So obviously the emulation is not completely frame locked because it's spewing a lot of debug bus information. But yeah, basically the palettes for the sprites look correct. Wow. Well, there we go. So proof that I can build relatively complex circuits. Fantastic. There was a little bit of a glitch there. So this proves that the code actually works. So I actually optimized and unrolled the sprite data copy loop, and you'll be able to see that in source code. So here we go. I'm getting a little bit of flickeriness now. I wonder what this is. It's ground myself. It might be overheating. It seems to be getting a little bit warm. Yeah, it's getting a little bit warm. So I think what's happening here is that I'm getting some problems. So if I reset the Commodore 64 now, boink. There we go. So this is indicative of some signal issues, perhaps. Or some memory, maybe some memory reading issues, or here we go. If I have grounded myself, but yeah, if I run my finger along the signal for the sprite fetching and stuff, no, okay, so maybe there's a slight heat issue or something like that. I think that's probably indicative of that. Oh, there we go. Oh, Oh, I can see what the issue here is. When I squeeze down here, so this is all the sprite loading and row and column information and stuff like that. The problems seem to fix themselves. So I think what that means is that I've got some slight connection issues with this area down here on the board. So if I squeeze it together, it's popped out. Basically, I think it's got a bit warm. So I've reset the Commodore 64, so that's stopped. So if I go back to Easy Transfer now and hit go again, Easy Transfer should run the code, Commodore 64 should come along, do its thing, and rerun the code, and then ding 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 ding, upload information complete. Oh look, that's interesting. After I squeezed the boards together, this sprite is no longer flickering. This one is a little bit jittery, but I think this is just a thermal thing. So yes, look, now I've squeezed them together properly, the signals. So this section down here, when I squeezed it together properly, this is for the sprite loading signals and all of the other goodness and stuff. So one moment. So if you look at the screen here, this is so on the sprite board. This is the sprite board. You can tell it's the sprite board because it's got these chips here and a resistor ladder on the right hand side. Just let me remove the rat's nest. Where is the rat's nest? There we go. Boink. Makes it a lot easier to see. So if I zoom in onto the sprite board down the bottom where I was squeezing the boards together, we can see it's video 3. And if I go to the schematic for this part, doink, video 3 is this part here. And as you can see, it's got all of the VPL, CDL, MDL, comp block, S-load, sprite loading, color data load, sprite definition, data load, etc., right? The 6 megahertz clock, vid clock, blah, 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 BG, border enable, display enable, VSync, HSync. So all of these lovely signals, when I squeezed it together, it looks a lot better. So there we go. I think I was getting I could definitely feel heat when I was putting my hand near there, and that's not a surprise because there are quite a lot of chips near the headers, especially the memory chips, and memory chips are being taxed pretty heavily. But this is good. This kind of like shows that my tweaks in terms of getting it all to run are pretty good. Definitely I need to sort out this board interconnect issue, but yeah, this is fantastic. This is really great. My word. Okay, I'm gonna leave this video here. I'm gonna now go get some sleep, happy in the knowledge that it works really quite well.